Okay. Next, next question talks about game theory terminology. Let's see if I can extend this a little bit larger to give us some more room to see. It says select a term that best describes each definition listed in the following table. And so we have definitions on the left side, and in the columns we have different terms. So let's take a look at the terms real quick. So first we have Nash Equilibrium, then dominant strategy, then it looks like collusion. Is there a scroll bar? Yep. Nash Equilibrium, dominant strategy, collusion, tit for tat strategy, payoff matrix, and prisoner's dilemma game. I don't think there's any more. Yeah, okay. And then the four definitions we have listed here. So let's take a look at the first one. First one says a player's best choice if it exists, regardless of his or her opponent's strategy. So there's not much to explain here. Like this is just stuff that you're gonna have to memorize and understand from a definitions point of view. So for this question, your strategy, regardless of what your opponent does, it doesn't change at all. That's going to be something that's called a dominant strategy. And it doesn't always exist, but when it does exist, it basically means you don't care what other people do, but you just do whatever you do, because no matter what, that's going to be your optimal strategy. So this is dominant strategy. Next definition says a set of strategies, one for each player, in which each player's strategy is the best option for that player, given the chosen strategy of the player's opponents. And so this is going to be basically an equilibrium point that you reach based on your assumptions for other players' choices. And it's going to be what we call Nash Equilibrium, a set of strategies for both parties that results in equilibrium given each other's strategy. The third says a case in which individually rational behavior leads to a jointly inefficient outcome. And that's going to be what we think of when we are talking about prisoner's dilemma game, where for those of you who aren't very familiar with game theory yet, basically, I think this is best explained with a prisoner's dilemma matrix. Basically, you're in a situation in which two people are arrested for committing a crime, they're partners in crime, and then they're interrogated separately and they're given a choice, right? They're given a choice to either turn on their partner, and this is probably a little bit easier to understand. So they can either turn on their partner, or they can not confess to the crime and kind of stay silent. And so by confessing to a crime, they would be turning on their partner. And so we can see here that in a traditional prisoner's dilemma matrix, oops, this looks like I went back. Just 1 second to get back to the right page, right? So anyways, so for this matrix, we can see that if both players are going to confess, and they both try to turn on each other, but if they both come clean, they both get 6 years in jail. However, if one player confesses and the other player doesn't confess, like in this square or this square, then the player who confesses gets no time in jail, and the player who doesn't confess gets 10 years in jail, because he basically gets thrown under the bus. And finally, the best strategy is if they both choose to remain silent, they get 1 year in jail for pleading to a smaller crime. And so that is going to be the best opportunity for them. So if they could collude and if they could work together, they would say, let's both not confess, and we would get to this optimal outcome of only serving 1 year in jail each. And yet, because they can't collude and they can't communicate, what you see is that the optimal strategy for both is to confess, and they'll end up in this square over here where they both serve 6 years in jail. And so that outcome of this kind of payoff matrix game is what we call prisoner's dilemma. And so that is the answer for this third definition. And finally, our fourth definition, a visual representation of a game showing all possible strategies for each player and all potential outcomes and payoffs. That's what we see right here. And this is an example of what we would call a payoff matrix. And so that was one of the answer choices as well. So that's all 4 definitions, and we can take a look at what the previous tutors have said. First definition, they said dominant strategy defines a player's best choice if it exists. Great. Second says Nash Equilibrium. We agree. Third says the prisoner's dilemma. And fourth says payoff matrix. So it looks like we are all in agreement here. So you can mark that as correct.